Hello everyone, welcome to Chaudhary Data World channel. Today I am here with a new topic on Pyspark, Dataframe and then RDD. So in this Databricks tutorial, this is going to be a very crucial and very basic topic for you guys, that what is RDD and what is Dataframe, how what are the benefits of both of them, what's the difference between both of them. All these things we'll be watching in this particular video in the detail. So let's get started with the video. So first one we are having into our list is RDD, and then we will move to data frame. So RDD and data frame both are there into PySpark as a data structure. It will be wrong to tell that PySpark only. It's basically for Spark, in which PySpark is just a API with which we are using in the Python language. So both of this RDD and data frame both are the basic data structure of Spark. Now the RDD, you can see here that we are having this particular syntax to create RDD. From PySpark import Spark context, and then Spark context object is getting created. That means by having a Spark context, app name equals to whatever you want, and then that Spark context object is getting passed with having one method. Suppose you are reading the text file, then dot text file, then it will be created against that RDD. And to display the RDD, we are using rdd.collect. But when it comes to the data frame, you can see here that the Spark object has been created by having a Spark session.builder or get or create, and then a spark.read.text. That's it. It is getting done. That means your df variable df will be containing that data frame, and which will be shown by this method dot show. Now let's jump to the PPT, in which we will be watching in detail what RDD is, what are its features, and then same for the data frame. So RDD is nothing but a resilient distributed data set. Now what this resilient is, we'll be watching here in this topic. What the distributed data set, we'll be watching here. One thing to note, that is it is one of the core data structure in Apache Spark. So the obvious question comes to anybody's mind, that what all other types of data structure available into PySpark or Spark. The other data structure are RDD, data frame, datasets, streaming datasets, and GraphX. So in this particular video, we are talking on this RDD and data frame only. In upcoming videos, we may cover these data structures as well. The third important point to note about RDD is that it is immutable distributed collection of objects. It's a very crucial point, and it's a very deep concept which it is right now telling in just a single statement, that it's immutable, which means that RDD, when it is getting created, that means when we saw in last Databricks slide, means when we were on Databricks portal, there we saw that we created RDD with one variable. That variable, or the data set which that variable would be containing, that can't be changed. Now question comes that how, if we want to have some transformation, then how we will go ahead with the transformation. So well, that transformation will be done on that particular data set by keeping that values, whatever the new transformed data will be there, it will be kept under a new variable. That means a new RDD. It means that whatever RDD which is pre-existing, it can't be changed. You need to create new one if you want transformation. Moving to the features, the first one is that it is a distributed, and here distributed means RDD is positioned across multiple nodes in a cluster. Of course, if you suppose you are having a data set, then subset of that particular data set will be uh, divided, and it will be divided on all of the nodes in a cluster. Hope you are already aware of what this cluster and node are. If not, you can check out my previous videos also, or in else if I can just create a new dedicated video against this node cluster and all, whatever database Apache Spark architecture we are having. So this distributed allowing parallel processing of data. When that data set will be divided into subsets of data, those subsets will be allocated to each of the nodes in the cluster. Nodes is nothing but, you can assume like this, that suppose you are having multiple machines, that you are having multiple systems or laptop, which laptop it is taken into one cluster. Suppose 5 laptops are there, and 5 laptops is having 4 cores into it. If it is your quad core, then 4 cores into it. And if there is second laptop again which is having 4 cores into it, again third, again fourth, all these cores are getting summed up into one laptop, and these 4 to 5 laptops are making one cluster. So this node is nothing but that laptop. So when that data set is getting divided or subset is getting allocated to some particular node of the cluster, it is called as distributed system. Correct. Each partition of an RDD can be processed independently on separate node. Of course. So whatever your data set or subset of data it is over there into on different nodes in a particular cluster, that will be handled separately. Because suppose you are having 10 data and you are having 5 nodes into some particular cluster on which that 10 data needs to be divided. So of course, suppose in layman term, 2 data it is divided on each of the nodes. So whatever transformation you will give command, those transformation or whatever the commands you are passing for those data set, all those things will be executed on each of the nodes separately, not at this once. So this is what this distributed mean. So in RDD, this is the feature which is basically there is in data frame also. And due to this region only, this major region only, Spark is even getting used. Because the biggest advantage to use is Spark instead of the on-premise system. This on-premise means if you are the traditional data managing system were there, right? So you were having only one laptop, and on that laptop or system you were just going ahead with having data manipulation. If you are aware of pandas and all, those are doing in such a way. But this Spark is making all the 3 to 4 laptops or 5 laptops, you can assume like this in layman, that 5 laptops has been allocated for the simple same task. Of course, that task which was getting handled traditionally into single laptop will become faster when it will be divided into 5 laptops. That means the data sets will be divided into all those 5 laptops, and then whatever the resulting processes will be, it will become faster. So this is the one of the most biggest feature of RDD. Then that is resilient. Another one is resilient. Resilient is RDD. Resilient means it is very much flexible, you may say. If you will search around the word of meaning of this resilience, it's flexible. Means RDD are fault tolerant. Now question comes that how it is fault tolerant. What it is having a specification that makes it fault tolerant. So for that we are having here, you can see the word Spark automatically track the lineage of transformation applied to RDDs. This is a heavy word which may confuse you, but hold on. Here it is telling that lineage of transformation. That means lineage is nothing but the track record, what the transformation going ahead. Suppose you have uploaded the data set. After uploading, you have renamed some of the column. After renaming, you have dropped some of the column. After dropping, you have added some particular column. So what you did 4 steps in whole of the transformation, correct? So all these 4 steps, whatever it has been already been occurred, those are there into the having those in that information as a line is, or it is called as DAG. It's a graphical representation in which it is getting stored. So due to this, that it is having memory to remember that what all transformations we already did. Due to that, this fault tolerance become this whatever fault detection becomes very much easy, since you are already having all the past histories, whatever transformation you did, it is there with you in the form of graph. So Spark automatically track the lineage transformation on RDD, which means it keep a record of original RDD and all the transformation applied to it. Of course, that's only the thing it is doing in Resi. Moving ahead with immutable, so it is read only and cannot be modified once created. Instead, we can apply transformation to create RDD based on existing one. The same thing which I mentioned, that whatever RDD you have created, that means whatever, suppose right now in Databricks portal we saw that we taken that RDD into one variable. That variable can't be changed. You need to create one new variable. New variable, it implies that you are creating a new RDD over there. So whatever transformation you want to make, you will be making it on a new RDD, not on the previous RDD. And the question of course comes to anybody's mind, that why even it should be mutable. If it would be mutable, it would be much more easier and convenient to go ahead with some other transformations as well. But if you will think of in this performance wise, or if you will think of in security wise, it is only the beneficial method, or it is only the beneficial way to move ahead with having larger data set. That means if suppose it will be immutable, if it will be read only, then of course security will be high. Another thing, that if suppose you are having your different RDDs for different transformations, then of course the things will become faster. If you want to retrieve the RDD, you need not to wait for some other transformation. You just will pulling out that RDD. So that all things are getting managed internally. You don't need to worry for that. But it is the reason that the speed is the reason due to which this is immutable. RDD is immutable. Another very important point about RDD, that is it is lazily evaluated. This is bit may sound technical to you, but it's nothing. It is only telling you that whatever you are actions and whatever transformations you have given, whatever transformation command, like suppose if you want to rename the column, if you want to count the column, then you want to drop the column, or whatever transformations you are having into whole of your chunk of code, those transformations will be applied on RDD, but it will not be given as the output until and unless one action has been performed. Suppose if a new command at last it is given as rdd.collect, then of course it will take out those that whole transformed RDD, and it will give you in front of you, which will show as the RDD. But until and unless you are giving that action command, that is .collect or something .take, if you are not giving that one, it will not be bothered to give you that RDD, which makes it pretty much faster. All the features whatever you are watching here from starting to last, all these are due to the speed and accuracy, to maintain speed and accuracy. So you can see here, transformation on RDD are evaluated lazily, meaning the execution is postponed until an action is triggered. The optimization allows Spark to optimize the execution plan and avoid unnecessary computation. Due to this reason only, that it is a lazily evaluated, all the things whatever you have transformed, it is stored into the form of graph. So later when we are doing transformation ahead, it is having in means we can just go ahead with having optimization of that. Correct. The last point we are having in memory computing. RDD can be stored in a memory, allowing faster data process and processing compared to traditional disk based processing. Of course, it is stored in memory, allowing faster data access. So RDD is something which is having in memory computing. That means it will improve the performance. That was whole about the RDD. Now moving ahead with the data frame. It's pretty much similar to RDD only. The major difference, let me first tell you the difference between both of them, so that you will be excited to go ahead with other information related data frame. So in RDD and in data frame, the biggest difference is that RDD can handle a lot and lot of flexible data. That means if you are having structured, semi-structured, non-structured data, all those data can be handled by RDD, but our data frame in Pyspark can only handle structured or semi-structured data. This was the first difference. Second difference, and the biggest difference again, data frame is having full convenience of visualization. That means it is in the form of tabular format, as you are watching into the SQL database or something like that, that it is into the tabular format, correct? But this RDD is not into the tabular format. Let me show you by going ahead into again in this. So you can see here that this RDD was into the format of this list, which is inconvenient to read, inconvenient to get understand that what it is even over there if you are having a large data set then. But this particular one, it is into the tabular format, which makes the usability more of data frame. So this data frame in again these two were the biggest difference between both of them, and you can see now the other literatures ahead that this data frame in Pyspark is a distributed collection of data organized into named columns. Of course, you got it, hope so. Conceptually similar to a table in a relational database, which I already mentioned that it's similar to the tabular format we are watching into some database like SQL. Distributed computing, of course, it is also a distributed computing for parallel processing of data, which I already mentioned into RDD. Same feature it is also having, that it is also a distributed computing. Immutable, again the same thing. That means whatever as RDD was immutable, this is also immutable. That means you need to create one new data frame if you want to have one transformation. Lazy evaluation, of course, it is we already covered up in RDD. That same feature we are having into the data frame as well, that it is having lazy evaluation. Coming to a schema, data frame has a schema which defines the name and type of the column in data frame. The schema enables a Spark to optimize query execution and perform various optimization. So it is having the well-defined schema, but in RDD we don't have well-defined schema. Its support for various data sources, but it definitely supports for various data sources. As you can see that whatever examples we are in front of us we are having. Integrated with a Spark ecosystem, of course it is getting integrated with a Spark ecosystem very well, and which I was mentioning the difference between RDD and data frame. Two differences I already mentioned, that RDD is very much flexible. It can contain any type of data, structured, unstructured, semi-structured. But data frame, it will contain only structured and semi-structured. Now this second the difference between RDD and data frame is that RDD, it is having a list like architect or a list like representation of data, but this data frame, it is having well defined schema which will show you as a tabular format. And the third most biggest difference between both of them, that RDD is not having optimization inbuilt. That means if suppose you are having some transformation applied on RDD, there is no inbuilt optimization with which we can optimize the transformations whatever it is so applied over RDD. But we get that facility into the data frame, that we can optimize, that there are several optimizers, built-in optimizers for Pyspark data frame, with which we can optimize our transformations very easily. So these were pretty much differences between both of them, that RDD and data frame. It's a very vital question which is in for a interview also, and if you are dealing up with into the practical scenarios as well. So if you are till here, kindly like to the video, subscribe to the channel, and thank you so much guys for watching the videos. If any confusion, let me know into the comment section. See you in the next one.